In this video, I'm going to talk about the factor theorem. According to the factor theorem, when a polynomial px is divided by a divisor ax plus b, if the remainder is equal to 0, then the divisor ax plus b is known as the factor of the polynomial px. In this example, I'm going to show you how to use the factor theorem and the remainder theorem in solving polynomial question. Given that x plus 2 is a factor of the polynomial px and px has a remainder of negative 35 when it is divided by x plus 3. Find the values of h and k. Since x plus 2 is a factor, means when the polynomial is divided by x plus 2, the remainder is equal to 0. So this one can be written as p negative 2 equals 0. And when the polynomial is divided by x plus 3, the remainder is negative 35. Based on the remainder theorem, this one can be written as p negative 3 equals negative 35. And since the polynomial is given here, now I'm going to substitute x with negative 2. So when I substitute x with negative 2, I should get a value 0. Then when I simplify, then I get a linear equation. And next, I'm going to substitute x with negative 3. So when I substitute this polynomial x with negative 3, I should get a value negative 35. So when I simplify, I get another linear equation. So now I have two linear equations. And I'm going to use equation number 2 minus equation number 1. So when I minus 2 with 1, then I get h is equal to negative 3. So when I substitute h equals negative 3 into the equation 1, then I get the value of k is negative 18. Now, if a polynomial px can be divided exactly by a quadratic divisor, and if the quadratic divisor can be factorized, then each of the factor in this quadratic divisor is also the factor of the polynomial. For example, the expression given here can be divided exactly by the quadratic divisor x power 2 minus 2x minus 3. Find the values of a and b. First, I'm going to write the expression in function notation. And when a polynomial is divided by a divisor, the result can be written as the polynomial equals the divisor times the quotient plus the remainder. Since the polynomial can be divided exactly by this quadratic divisor, so the remainder is equal to 0. And when I factorize this quadratic divisor, I find that it is equal to x minus 3, x plus 1. So from this equation, we know that x minus 3 and x plus 1 are the factor of the polynomial px. Since we know that x minus 3 is a factor of the polynomial, so when I substitute the x in a polynomial with 3, and I should get the value of equal to 0. So when I simplify, I get a linear equation here. And we have another factor that is x plus 1. Since x plus 1 is another factor, so when I substitute the value of x in a polynomial with negative 1, then I should get the remainder equals 0. So when I simplify, I get another linear equation. So now I have two linear equations. So now I can do simultaneous equation. I use the first equation minus the second equation. Then I'll get 8a equals 24. Then a is equal to 3. So when I substitute a equals 3 into the second equation, now I get b is equal to -5. Now I'm going to show you how to use factor theorem to do the factorization of polynomial with higher degrees. Actually, there are many methods can be used to factorize a polynomial with higher degree. So in this video, I will focus in using factor theorem. So when a polynomial px has a factor ax plus b, px can be written as ax plus b times the quotient, and since ax plus b is a factor, so the remainder is equal to 0. And if a polynomial has two factors, then px can be written as this first factor times the second factor times the quotient, and the remainder is equal to 0. And if ax plus b is the factor of a polynomial, then we can say that x equals -b over a is the 0 of the polynomial. Because when we substitute the x with -b over a into the polynomial, then the result is equal to 0. So that's why we call it as 0 of the polynomial. And if ax plus b is the factor of the polynomial, then this value of x equals -b over a is also known as the root or the solution of px equals 0. So according to the diagram, the root of px equals 0 is the values of x when the polynomial cuts through the x-axis. That is, the root actually is the x-axis of the graph of the polynomial. Now let's try this question. The polynomial px is given here where a and b are constants. It is given that px has a factor x minus 1 and has a remainder of -49 when divided by x minus 2. Okay, first we are going to find the values of a and b. So based on the information, we know that x minus 1 is a factor. That means that when the polynomial is divided by x minus 1, the remainder is equal to 0. So for this, we can write p1 equals 0. And the remainder is 49 when the polynomial is divided by x minus 2. So for this, we can write it as p2 equals -49. From the first information, we know that we are going to substitute the value of x with 1 into the polynomial. So when I substitute x with 1 in the polynomial, then I should get a 0. So when I simplify, now I get a linear equation. For the second information, now I'm going to substitute x with 2 into the polynomial. So after substitute x with 2, then I should get a -49. And when I simplify, then I get a linear equation. So now I have two linear equations. So now I can do the simultaneous equation to find the value of a and b. Okay, so I use the equation 2 minus equation 1. So I get 3a equals 9 and I get a equals 3. So when I substitute a equals 3 into the equation 1, then I get b equals 17. Now question B, factorize the polynomial completely. So first, I substitute the values of a and b into the polynomial. Then, since x minus 1 is the factor of this polynomial, so means px also can be written as x minus 1 times the quotient, and since the factor is x minus 1, so the remainder is equal to 0. So to factorize this px completely, so now I'm going to find the quotient. So to find the quotient, based on what we learned before this, we can use long division or equating the coefficient to find the quotient here. So now I'm going to use the long division method to find the quotient. Now how to use the long division to find the quotient? You can refer to my previous video talking about the long division. In that video, I have explained in detail how to use the long division method to find the quotient. So after the long division, I find that this is the quotient. So now I write down the quotient here. That is the quotient I take from the long division here. So after I have got the quotient, since this quotient is a quadratic expression, so now I have to make sure whether I can factorize this quadratic. If this quadratic can be factorized, then we must factorize this quadratic. So since this quadratic can be factorized, so after factorize, then I'll get these two factors. So after factorize the quadratic, so now I have already factorized the polynomial completely. Now question C. State the zeros of the polynomial px. From part B, since we have already factorized the polynomial where the polynomial is the product of three factors here, so means when we substitute the polynomial with the values of x here, we should get a 0. So means that value of x is the zeros of the polynomial. So therefore, the zeros of the polynomial px are 1 and negative 1 over 3 and 9. Now we move on to the next example. The polynomial px is given here. This polynomial can be divided exactly by both x minus 2 and 2x plus 1 respectively. So first, find the values of a and b. Now since we are given that x minus 2 and 2x plus 1 are the factor of this polynomial, so we can write it as p2 equals 0 and p negative 1 over 2 equals 0. For the first one, when we substitute x with 2 into the polynomial, then we should get a 0 here. So after simplifying, I get a linear equation. For the second factor, when I substitute x with negative 1 over 2 into the polynomial, I should get 0. Then when I simplify, I get another linear equation. So now I'm going to do simultaneous equation. So for this linear equation, I'm going to substitute 2 into the equation 1. That is, I substitute a with 2b plus 24. So when I substitute a into the first equation, when I simplify, I get b equals negative 13. So when I substitute the value of b back into the equation 2, then I get value of a is negative 2. Now question B, factorize the polynomial px completely. So first, I substitute the values of a and b into the equation. And since x minus 2 and 2x plus 1 are the factor of this polynomial, so means that this polynomial also can be written as px equals first factor times second factor times the quotient, and the remainder is equal to 0. So now to factorize this polynomial, I'm going to find this quotient. So to find this quotient, we can use long division or equating coefficient. So in this question, I use long division method to find the quotient. After the long division method, now I'm going to take the quotient from the long division and substitute into the polynomial here. Now I get this one. So now since this quotient is quadratic, so we must always double check whether this quadratic can be factorized. And we find that this quadratic is not be able to factorize anymore. So now means I have already complete factorized the polynomial. Now question C, find all real roots of px equals 0. So from the answer of part B, we have already factorized the polynomial. And since we are given that px equals 0, so means that this one is equal to 0. So now based on this equation, now we know that x minus 2 is equal to 0, 2x plus 1 is also equal to 0, and this x power 2 plus 2x plus 3 is equal to 0. So based on here, x is equal to 2. Based on this one, x is equal to negative 1 over 2. Now for this one, to find the values of x, now I'm going to use the formula, that is the formula to find the values of x of the quadratic equation. So when I simplify, I find that this is a square root of negative 8. When this is a square root of negative 8, actually this is a complex number. So complex number that we are going to learn in chapter 3. So now since question asks for real roots, means the answer should be a real number. So means the complex number, we are not going to take the complex number as the answer. So we give the reason that the x here is not real roots. So therefore, the real roots are x is equal to 2 and x is equal to negative 1 over 2. Now we move on to this example. Factorize this polynomial completely. So for this question, we are not given any additional information to do the factorization. That is different from the two examples before this, where we are given the first factor of the polynomial, then after that we continue to do the factorization. But for this example, we are not given any information. So now, to find the first factor of the polynomial, we are going to use the trial and error method. So to find the first factor by using trial and error method, that is, we simply choose values of x and substitute into the polynomial. If the result is equal to 0, then we will get our first factor. If the result is not equal to 0, then we will ignore these values of x and we continue to try other values of x until we get the 0. And this process is quite time consuming. To save the time from doing the process of trial and error, we can use the possible number here. That is, we use the factor of the last number divided by the factor of the first number. So in this question, the last number, the constant is 2. The factor of 2 is 1 and 2. And the first number is 18. So the factor of 18 is 1, 18, 2, 9, and 3, 6. So the possible value we can choose to do the process of trial and error, that is, we can choose 1 over 1, that is 1. But we find that that is not equal to 0. So we try the second value. We can try 1 over 2, or we can choose 1 over 3. We can choose 1 over 6, or we can choose 2 over 1, that is 2. We can choose 2 over 2, that is 1, 2 over 3, 2 over 6, and so on, until we get a 0. That is, we will get the first factor. For the first choice, when I substitute 1 over 1, that is 1, I find that it is not equal to 0, so I ignore the 1. So now I continue to the second choice. I try 1 over 2. So when I try 1 over 2 and substitute x equals 1 over 2 into the polynomial, when I calculate, I find that it is equal to 0. So once I get this equal to 0, so means I get the first factor. So the first factor is 2x minus 1. Once I have got the first factor, now I can write the polynomial in this form. That is, polynomial px is equal to the factor times the quotient. So the remainder is equal to 0. Now I'm going to find the quotient here. So to find the quotient, I can use the long division method, or I can use the equating the coefficient. So here I use long division method. I find that the quotient is this one. So now I write down the quotient here. After I have got the quotient, I find that this quotient is a quadratic. Now I have to make sure whether I can factorize this quadratic. So when I try to factorize, I find that the quadratic can be further factorized into these two factors. So after the factorization, now I have already factorized the polynomial completely. Actually, we have another method to find the quotient of this polynomial. That is, I can use equating the coefficient. To use the equating coefficient to find the quotient here, first I'm going to list out all the terms of polynomial px. And for the quotient, since the polynomial is in degree 3 and the divisor is a linear, then the quotient will be a quadratic. And since we do not know the quotient, so for time being, we use the unknown form to write down the quotient in quadratic. In order to make our working step becomes easier, now I'm going to take the first term in each factor here, and when I multiply the first term in each vector here, the result is the same as the first term in the polynomial here. So 2x times ax power 2 should be equal to 18x power 3. So for the coefficient, so I should think 2 times what? We get 18. So definitely 2 times 9 is 18. So a is equal to 9. Then similarly for the last term, that is the constant. So now I take all the last term, that is the constant, from each of the factor here. So when I multiply these two constants, the answer is same as the constant of the polynomial. That is negative 1 times what? We get positive 2. So definitely negative 1 times negative 2, I get positive 2. So C is negative 2. So means here I have only one unknown to find. And this method is only valid for the first term and the last term. So for the terms in between here, we are not allowed to use this method. So to find the b here, we are going to compare the coefficient. Either compare the coefficient of x squared or coefficient of x. So now I'm going to compare the coefficient of x squared. For the left hand side, coefficient of x squared is -3. Then on the right hand side, we are going to find one by one the term with x power 2. So we find that 2x times bx is 2bx power 2 and the coefficient is 2b, and -1 times 9x power 2 is -9x power 2, so the coefficient is -9. So from here, we find that b is equal to 3. After I have got the value of b, now I substitute the b with the value 3. So now I have got the quotient q is equal to the quadratic here. Then I'm going to factorize this quadratic to complete the factorization. So after factorize the quadratic here, now this is the answer. Next, we try this question. Factorize this polynomial in degree 4 completely. Since this question we are not given any information, so means we are going to find the first factor by using trial and error method. So first, I try to write this polynomial in the function notation. So when I do the trial and error, I try to substitute x with 1 and I calculate, I find that it is equal to 0. So now I got the first factor, that is x minus 1. So once I have got the first factor, so the polynomial can be written as px equals the first factor times the quotient. The quotient can use any function notation. So now in this example, I use fx as the quotient. So now I'm going to find this quotient fx. And I use the long division to find the quotient fx. From the long division, the quotient is this one. So now I write down the quotient here. Now to continue the factorization, now I'm going to focus at this one. That is x power 3 minus x power 2 minus x plus 1. So now let fx is equal to this polynomial in degree 3. And I will repeat the same process. That is, I try to choose any values of x and substitute into this polynomial. And when I choose x is equal to 1, I find that the result is equal to 0. So once again, for this polynomial, the factor is x minus 1. So means fx can be written as x minus 1 times another quotient. So now here I use gx as the quotient. So now I'm going to find gx by using long division. So after long division, I find that the quotient is x squared minus 1. So after I have got this one, I'm going to substitute the fx back into the equation 1 just now. So when I substitute, I got this one. Then when I look at this quadratic, I find that I can further factorize this quadratic becomes this one. So when I look at here, there are 4 linear factors. But the 4 linear factors, the first and second and third factors is the same. So when I combine the same factor, so now I get x minus 1 power 3. So now I have complete factorized this polynomial. To factorize this polynomial, actually we have another method. So first, we use the trial and error to find the first factor. So when I substitute the x with 1, I find that the answer is 0. So I get the first factor, that is x minus 1. Now I continue to do the trial and error until I get the another factor. So when I substitute x with -1, I find that the answer is also equal to 0. Means I get another factor of this polynomial. Since I have got two linear factors of the polynomial, so now px I can write it as px equals the first factor times the second factor times the quotient. So now I'm going to find this quotient and I'm going to use the long division. Of course, you can use the equating coefficient method. So after long division, the quotient is this one. So now I replace this quotient with this quadratic. After that, I need to confirm whether this quadratic can be further factorized. So I find that I can further factorize this quadratic. So once I have factorized the quadratic, I find that I have three similar linear factors. So when I combine, I get this one. So now I have finished factorized the polynomial completely. I think that's all for now. If you think that this video is beneficial, please give me a like and share to your friends. Thanks for watching.